Okay, hi everyone. My name is Emily Kondo, and today I will be presenting on the research I did on the question, is there a presence of methicillin-resistant Staphylococcus aureus in public beach showers around the island of Oahu? So with a show of hands, how many of you know what methicillin-resistant Staphylococcus aureus is? So not too many of you, right? Those who did maybe either heard about it from me or from the news. But methicillin-resistant Staphylococcus aureus, better known as MRSA, has been a big topic in Hawaii and throughout the United States. So as many as 200 people in Hawaii die annually because of a MRSA infection or its complications. To put that into context, from 2013 to 2015, on average 266 people died annually because of diabetes. So obviously this issue is quite large. Furthermore, Hawaii has twice the national average of people hospitalized with MRSA infections. And this national average isn't a small number. Over 72,000 cases come in annually with people hospitalized with MRSA infections, with over 9,000 deaths. And as you can see in this graph, in this graph, the numbers only continue to climb. So in the green chart here, it's a little bit hard to see. Sorry about that. We can see that the percent of resistance in the genes of the United States is quite high for a fully developed country. And this is all because of the unique nature of MRSA. Because it is resistant to so many of our everyday antibiotics, it is extremely hard to treat. So the question is, where is MRSA found? MRSA has been found in many public places, including hospitals, athletic facilities, which are like gyms and weight rooms, military barracks, prisons, schools, and even public transportation. And kind of the relating factor between all of these are that they are densely used by a lot of people. And so MRSA is transmitted from person to person through either skin contact or contact with contaminated surfaces. And so this all led me to my question, where is MRSA found in Hawaii? Scarily enough, studies have been seen to isolate MRSA from marine water, stream water, and sand samples from California, Hawaii, Florida, and the Pacific Northwest. What is even scarier is that Hawaii studies have found that it is able to survive on contaminated surfaces and has now been found in our Hilo watersheds. And so a little bit of background on MRSA. So methicillin-resistant Staphylococcus aureus, I'm going to refer to it as MRSA throughout my presentation, is a type of Staphylococcus bacteria. Many of you have probably either had a staph infection or know someone who has. So in general, they're not too dangerous and can usually be easily treated using antibiotics. But because MRSA is resistant to so many of our everyday antibiotics, that's where the danger comes in. And it can even become fatal if not treated. So MRSA in specific is resistant to all the beta-lactam antibiotics, which include methicillin, penicillin, oxacillin, and amoxicillin. You guys have probably heard those words in your doctor's office. And they're all commonly used to treat infections, which, because MRSA is resistant, that's why we can't treat it so easily. And so now you're probably wondering, how do I know if I have a MRSA infection? Well, you'll probably be glad to know that none of you have MRSA infections, because common symptoms include extreme skin infections, pneumonia, organ infections, sepsis, and the infection of a bloodstream. So after reading about all the horrible effects, statistics, and history behind methicillin-resistant Staphylococcus aureus, I learned that the most readily supplied solution to contamination while at beaches is to simply use the beach showers. So this was when I realized there was an extreme gap in knowledge about MRSA and what we know about its presence in beach showers. And so this brought me to my question, is there a presence of methicillin-resistant Staphylococcus aureus in public beach showers around the island of Oahu? So to address my question, I collected 40 samples from 32 sites around Oahu. To do so, I used MRSA-specific growth agar, which was specially made to grow only bacteria that were resistant to the same things that MRSA was resistant to, and cotton tip swabs to sample around the surface of the floor of the beach shower. So that'd be around here. And that's normally where people stand. That's how I kind of chose where I was sampling. So these two are pictures of two of the sites I sampled, and then in the middle are my materials. So this is a map of where I sampled around the island. I chose my locations based off A, they needed to have a beach shower, of course, and then B, I wanted to get a wide range around the island so I could really get an idea of whether it was present on Oahu at all. From there, I cultivated my samples by incubating my plates at 27 degrees Celsius for 24 hours. If after an initial period of 24 hours there was growth, they were taken out and photographed. But if there was no growth, they were returned for an additional 24 hours as instructed by the manufacturer. Okay, so to determine if there was MRSA in my samples, I had a two-step verification process. So the first step was based off of color. So these plates were specially made so that any possibly MRSA bacteria would grow this purpley kind of magenta color, like that, while all other antibiotic-resistant materials would grow teal, as you can see on that picture. And so I wasn't 100% certain that that was going to be accurate because I had quite a bit of magenta growth. So to kind of verify this all, I sequenced the DNA, and so I could ensure that my results were correct. And so this is a distribution of what the colony growth looked like. As you can see, about 40% of the samples grew some sort of magenta, meaning that if I had just left myself with just kind of the visual test, it would have come out as 40% of samples would have had MRSA. Okay, so once growth was found, I extracted the DNA of the bacterial colonies, and they were run through a polymerase chain reaction and sent off for sequencing. And lastly, I compared my sample DNA to known genomes from GenBank to determine what they were. So I have included a picture that kind of just shows how we compare genomes to known genomes. So on the top level, in kind of the grayish color, is the MRSA complete genome, while I have included 4 different comparison sequences. So anywhere there's like disconnects, and so those are where there are differences in the base pair differences, and then that shows that the specific sequences I'm comparing here are not MRSA. And so overall, there was no MRSA found, but it's actually a really good thing that we don't have MRSA in our beach showers. But however, there was harmful antibacterial resistant bacteria found. So of the bacteria I found, 30% were considered harmful, which means they are capable of causing skin infections, sepsis, or some other type of infection. So normally most of these kind of strains would be pretty harmless because of the easy treatment of antibiotics. But with their antibiotic resistance that we can see through the fact that they grew on the plates, they stand to pose significant threats. So the realization that there is so much antibiotic-resistant material in our showers begs the question of how we protect ourselves from it. What steps do we need to take as individuals and as a state to combat this problem? And the problem as a whole really is the problem of antibacterial resistance. So antibiotic resistance occurs when bacteria becomes resistant to the antibiotics we usually use to treat them. So that those are things like MRSA. And so they can actually develop into superbugs, which are a term we usually use to describe bacteria that are resistant to the majority of all the antibiotics used today. And so the development of antibiotic resistance isn't something we can necessarily stop. There are definitely ways to slow it. And so things that accelerate antibiotic resistance include missing your antibiotic treatments, so that you take like half your treatment because then you get better and then you stop, or living in unsanitary conditions. So to combat the rapid growth of antibiotic resistance, you can use your antibiotics as directed, complete your full treatments, and then never share or exchange antibiotics. That's not a good idea. Okay, so now for my takeaways. I can honestly say that this has been one of the most rewarding experiences I have had during my time at Iolani. It not only allowed me to gain experience in the lab environment, but it allowed me to explore science individually. While I have always enjoyed science, I have often felt stifled by the requirements of a lot of courses. Rather than being required to learn about things that I have no interest in, this course allowed me to explore my own questions and pursue my own thoughts. So the independent nature of the class really encouraged me to be self-motivated, and it made me that much more invested in what I was doing. In a lot of ways, this helped me to reinvigorate my love for science and learning. And I think that oftentimes we like to say that we like a subject because we're good at it, but doing something like this independent research really makes you wonder why you love something, and it makes you reevaluate your interests. And so during those tough times when my research didn't come out as I wanted, or when I was cramming last minute, sorry, Dr. Chan, for the next day, I kept coming back to my own personal investment. And so because of all these reasons, like Dr. Chan was saying earlier, I strongly suggest that anyone who has some sort of interest in research either do it here or maybe in college if you're a senior, and just take the plunge. Okay, so I would like to acknowledge Dr. Chan, who was not just my teacher, but she was kind of my mentor. She taught me everything I know. Mr. Tong, he was the one who came in during our breaks to open up the lab so I could do my work. My period 3 research class, who were the most amazing people ever and supported me and actually cheered when I got staff as a result. And then everyone along the way who has helped me. Thank you.